Hello, welcome to Arithmetic Momentum. This is the physics portion of Arithmetic Momentum, where we'll be going over basic concepts that high school students transitioning to college that need extra support will need to know. Now, this is a simple kinematics problem that will really help students and guide them through this type of concept and understanding the steps of how to solve these problems. Now here, a car is traveling at a rate of 300 meters per a time of 12 seconds. The mass of the car is 700 kilograms. Calculate A, the momentum of the car, B, the kinetic energy of the car, and C, given that the car accelerates at a rate of 34 meters per second square, determine the displacement of the car. Now, first we're starting out with the momentum of the car. Now, momentum is, in physical terms, described by P. And P, momentum, is equal to the mass times the velocity. Now, we already know that the mass of the car is 700 kilograms. So we can just write that. But we don't have the velocity. We only have 300 meters at a rate of 12 seconds. So, how do we determine the velocity? Now, the velocity is usually determined by the distance over the time. So we already have 300 meters. We'll use that as our distance. Over 12 seconds. This gives us a velocity of 25. And now, don't forget the units, it's meters per second. This gives us our velocity, but we're not done yet because we need to determine now the momentum. So then the momentum is equal to the mass, which is, as we know, 700 kilograms. Times the velocity, which is the value we just determined, 25 meters per second. And now, if we multiply this, we get that the momentum is 17,500 kilograms times meters per second. That gives us our momentum. Now, for the next step, we want to determine the kinetic energy of the car. Now, the kinetic energy is conceptually determined by a formula where kinetic energy is half times the mass times the velocity squared. Now, the good thing is we already know that the mass is 700 kilograms and that our velocity is 25 meters per second. So this is a simple substitution problem where we get that the kinetic energy is 1/2 times 700 kilograms as the mass, and then times the 25 meters per second squared. Now, I like to solve this starting off from the back. 25 meters per second squared, that will be equal to 625 meters per second. Now, multiplying that by 700 kilograms and times 1/2. We multiply 625 by 700 by 1/2. That will give us 218,750 joules. Now we can use this, but it's better if we make it as efficient as possible and put it into simpler terms by converting joules to kilojoules, which will give us a smaller and better number. Now, this conversion is not necessary here. It's just a way of making a smaller and more concise value. Now, last but not least, given that the car accelerates at a rate of 34 meters per second square, determine the displacement of the car. Now, displacement has a very interesting formula because displacement involves the initial velocity times the time plus half of the acceleration times the time squared. Now, the initial velocity was already determined when we got 25 meters per second. So we can say that our velocity is 25 meters per second because the car is traveling at a constant rate initially. Now, for the acceleration, we have that the car picks up speed and begins driving at 34 meters per second squared. So that would be like our acceleration in this case. So this problem in particular is a simple substitution problem where we would just substitute 25 meters per second times the t, which is our time, 12 seconds, and then plus half the acceleration, which is 34 meters per second squared, times the time squared. Now, all we really have to do here is multiply this 25 times 12. If we plug that in, we would get 300 meters, because the s cancels out, plus if we multiply this, we get that 12 seconds squared, that's 144, times 34 times a half, that will give us 2,448 meters. If we plug this all in and multiply, if we put in a calculator, which will give us a final value of our displacement to be 2,748 meters. And that's how you would determine the momentum, the kinetic energy, and the displacement of the car. Thank you.